Okay, so I just want to give a quick reminder again about the relation between sampling interval, which we're calling t, and sampling rate or frequency, which we're calling f. So in particular, I want to explain again how this is an inverse relation. So that means that if the sampling interval t gets smaller or goes down, that implies that the sampling rate or frequency f gets higher or goes up. So let's see why that is or how that happens. So remember we were talking about how a sound wave is an analog signal, and here on the y-axis or vertical axis we have amplitude, so that could be, for instance, amplitude in the air pressure when in the air pressure variations, and then here on the x-axis or the horizontal axis we have time measured in seconds. Okay, so now suppose that we are trying to sample this, so we want to sample this analog signal here. Okay, so now let's say that our sampling interval is t equals 0.5 seconds. Alright, so let's say we have sample at the beginning. We would take another one at 0.5 seconds and then yet another one here at 1 second. Then we can ask the question of how well are we covering this analog signal? Well, one way to see that is by interpolating between our samples. So remember we have our sample here, and our sample here. That's all the information we're getting about the original signal. So if we interpolate by connecting the dots, then we can see roughly the kind of shape we're getting. And what you can see is we're completely missing this peak. And we're missing this little valley too. Although we're capturing that this is a point at which the wave is rising. But yeah, we're completely missing that. So also, let me remind you how we get to the frequency from here. So f is 1 over t, and that's going to be 1 over 0.5 seconds, or that is 2 samples per second. So in other words, we have that a sampling interval of 0.5 seconds corresponds to a sampling rate of 2 samples per second. Okay, now you might be saying, well, wait a minute, but there's 3 points here, 1, 2, 3. What are you telling me this should be 2 samples per second? It looks like we have 3 samples per second. Well, this is just because we have this initial kind of sample at time 0, and you can see as as we have a longer and longer time interval where we're sampling, this kind of extra sample goes over a ways. So you can see if we had 3 seconds, here we have a sample at 0.5, at 1, at 1.5, at 2, at 2.5, at 3, and then we have this sort of extra one at the beginning. And this is going to be 1, 2, 3, 4, 5, 6, 7 samples, but you can see that's just because there's like this little one extra kind of sample at the beginning, and if we had way more time, then that little extra sample would be just one tiny one compared to the many other samples we're taking. So now what if we increased what if we decreased our sampling interval t and had it as 0.25 seconds? Okay, then in that case, that would mean we would take, let's again, we have our little, like extra buffer sample at the beginning. Then we take a sample at 0.25 seconds, 0.5 seconds, 0.75 seconds, and 1 second. And so we have measurement here, measurement or sample here, another sample here, and a sample here. So then now how well are we recovering this original green analog signal? Again, we can get a sense of that by seeing what happens when we interpolate between our points. So connect this, connect that, connect this, and connect that. And so you can see that now we're getting this up and down shape. In fact, this sample here happened to coincide with the peak in the original signal. So now compared to our original sampling interval of 0.5 seconds where we completely missed this, so we got this shape of kind of flat and then going up, you can see we're doing way better here. We're going up and down and up, missing a little bit of that dip there, but we're still doing quite good. Now, in terms of calculating the frequency, again, that's going to be f equals 1 over t, and that's going to be 1 over 0.25 seconds, and that's going to be 4 samples per second. So remember again, we have that extra little buffer guy here at the beginning, so that's why there's 5 points here instead of 4. And so just to wrap up, you can see that here where we had t equals 0.5 seconds, a bigger sampling interval, we had a frequency of 2 samples per second, and we were missing some detail here in the original signal. But then when we had a smaller sampling interval, we cut it in half to 0.25 seconds, our frequency went to 4 samples per second, or twice as high as our original one, and we got a much better recovery of the original shape. So yeah, that's going back again to our inverse relation between sampling interval and sampling rate, where if the sampling interval goes down, in this case from 0.5 to, well, I can write it, I guess. So if we went from 0.5 seconds compared to 0.25 seconds, you see that resulted in a sampling frequency of 2 samples per second as opposed to 4 samples per second. Okay, great.